Look up at the night sky tonight. Among the thousands of stars visible to your eyes somewhere out there, hurtling through the darkness at 200,000 kilometers per hour, is a visitor from another star system. Its name is 3I Atlas, and Carl Sagan knew it was coming. In 1980, when 500 million people around the world tuned in to watch Cosmos, Sagan shared a vision that seemed almost like science fiction. He spoke of objects wandering between the stars, ancient travelers carrying with them the secrets of distant stellar nurseries. He predicted that someday we would detect these cosmic vagabonds passing through our solar neighborhood. He understood, through mathematics and physics, that the galaxy must be filled with such wanderers. 40 years after Cosmos first aired, we are witnessing the validation of his scientific intuition. Carl Sagan believed that science was not merely a body of knowledge, but a way of thinking, a way to distinguish what is true from what we wish to be true. And what he told us about interstellar visitors was grounded not in fantasy, but in probability, in the laws of orbital mechanics, and in a deep understanding of how solar systems form and evolve. If you want to continue Sagan's mission of cosmic exploration, to see the universe as he taught us to see it, with wonder tempered by reason, join this journey by subscribing. Help us spread this perspective by sharing these ideas with others who look up at the night sky and ask the same questions Sagan asked. What would Sagan have seen in this visitor from beyond our sun? The answer reveals something profound about the nature of the cosmos itself and about our place within it. On the 1st of July 2025, astronomers detected something extraordinary. The Asteroid Terrestrial Impact Last Alert System, ATLAS for short, captured an object moving through space at a velocity that immediately caught attention. Within 24 hours, as orbital calculations poured in, scientists around the world realized they were witnessing something rare. The numbers told a story that defied the normal patterns of our solar system. 3I Atlas is traveling at 58 kilometers per second relative to the Sun. To put that in perspective, that is more than 200,000 kilometers per hour, fast enough to travel from Earth to the Moon in less than 2 hours. But speed alone does not make this object special. What matters is the shape of its path through space. Every planet in our solar system follows an elliptical orbit. Comets born in our solar system, even those from the distant Oort cloud, trace elongated ellipses that eventually curve back toward the Sun. Their eccentricity, the measure of how stretched their orbits are, never exceeds 1.0. An eccentricity of exactly 1 would be a parabola, the boundary between bound and unbound motion. Anything above 1, and the object is not bound to our Sun at all. It is merely passing through. 3I Atlas has an orbital eccentricity of 6.141. This is the highest eccentricity ever recorded for any object in our solar system. Its trajectory is not a closed curve, but an open hyperbola, a path that entered our solar system from interstellar space and will exit back into the void between the stars. When astronomers traced its trajectory backward through time, they found that it came from the general direction of Sagittarius, from the thick disk of our galaxy, where ancient stars orbit in paths inclined above and below the galactic plane. This is only the third confirmed interstellar object humanity has ever detected. The first was Oumuamua in 2017, that enigmatic tumbling rock that sparked 1,000 speculations. The second was 2I Borisov in 2019, a more conventional comet that behaved much like the icy bodies native to our own solar system. Now comes 3I Atlas, moving faster than its predecessors, following a trajectory so close to a straight line that it barely bends as it passes through the inner solar system. Observations from telescopes around the world, including pre-discovery images dating back to mid-June, have allowed astronomers to pin down its properties with precision. It is a comet, shedding gas and dust as the sun's heat warms its ancient ices. Spectroscopic analysis reveals familiar molecules, water and carbon compounds, the basic chemistry of comets everywhere. Yet this is no ordinary comet. This is a relic from another star system, 3 billion years old by some estimates, older than many of the features of our own solar system's architecture. Carl Sagan would have been fascinated by these details, not because they are exotic or alien in the sensational sense, but because they are exactly what his physics predicted. In his book, Pale Blue Dot, published in 1994, Sagan explored the mathematical probability of interstellar comets. He understood that the process of planetary system formation is chaotic and violent. Young star systems are cluttered with leftover debris, icy bodies, and rocky fragments that never coalesced into planets. Gravitational interactions, especially with giant planets like Jupiter, can fling these objects outward at tremendous speeds. Some achieve escape velocity and are cast into interstellar space. Sagan calculated that the galaxy should be filled with such wanderers, trillions upon trillions of them, drifting in the dark between the stars, taking millions of years to travel from one star system to another. Occasionally, purely by chance, one would pass through another star's domain. He predicted that we would eventually develop the technology to detect these rare passages, and he was right. Consider the scale of what is happening here. 3I Atlas likely formed around a star that existed before our Sun ignited. It was ejected from its birth system billions of years ago, perhaps when a newly formed giant planet migrated inward, scattering the smaller bodies that shared its neighborhood. It has been wandering the galaxy ever since, traveling through the cold and the dark, seeing nothing, feeling nothing, a frozen time capsule from an era when our solar system did not yet exist. By pure chance, its trajectory intersected with our Sun's gravitational sphere of influence. For a brief moment in cosmic time, a few months out of billions of years, it passes close enough to a star to warm its surface, to release gases that form a faint tail, to be illuminated by starlight and detected by creatures on a small rocky planet who have learned to build telescopes and ask questions about their origins. Sagan taught us that extraordinary claims require extraordinary evidence. This is his famous standard, the principle he used to evaluate everything from UFO reports to claims of ancient astronauts. So let us apply it here. Is 3I Atlas extraordinary? Yes, in the sense that it is rare and scientifically valuable, but is it evidence of anything beyond natural astrophysical processes? The data says no. Some have speculated, as they did with Oumuamua, that interstellar objects might be artificial, constructed by extraterrestrial civilizations. Sagan himself was deeply interested in the possibility of life beyond Earth. He was a founder of the Search for Extraterrestrial Intelligence, SETI, and he spent decades thinking about how we might detect signals from other technological societies. But he also insisted on rigor. An anomaly is not evidence of intelligence. An unusual orbit is not proof of technology. 3I Atlas behaves exactly as we would expect a natural comet to behave. It outgasses as it approaches the Sun, producing a coma and tail from sublimating ices. Its trajectory is explained entirely by gravity and the small non-gravitational forces produced by jetting gas. There are no signals, no unexplained accelerations beyond what we see in every active comet, no characteristics that require anything other than natural processes to explain. This is Sagan's legacy of skepticism at work. It is not about refusing to wonder. It is about distinguishing between what we observe and what we imagine. It is about holding our speculations accountable to evidence. Sagan would celebrate the discovery of 3I Atlas, not because it is mysterious in the paranormal sense, but because it is mysterious in the scientific sense. It poses questions we can actually answer through observation and measurement. What questions does it pose? Where exactly did it come from? Can we trace its orbit back far enough to identify a potential parent star system? What is its exact composition, and how does that compare to comets born in our solar system? Are there subtle differences in chemistry that might reveal different conditions in the molecular cloud where its parent star formed? How many more such objects pass through our solar system undetected because they are too faint or we are not looking in the right direction at the right time? These are the questions that drive science forward. They are the questions Sagan would have asked. And they are questions we can begin to answer with the tools we have built. The telescopes on Earth and in space, the networks of observers scanning the sky every clear night, the computer programs that sift through millions of data points looking for the anomalies that signal something new. In Cosmos, Sagan took us on a journey through space and time. He showed us the births of stars in vast clouds of gas and dust. He walked us through the formation of planetary systems, with rocky worlds close to their suns and icy bodies in the outer reaches. He explained how these systems evolve, how planets migrate, how leftover debris is either swept up by planets or ejected into interstellar space. He was describing the process that created 3I Atlas. Though he did not know this specific object would arrive in 2025, he understood the physics, he grasped the implications. He knew that if his model of star and planet formation was correct, then interstellar comets must exist in vast numbers. The discovery of 3I Atlas and its predecessors validates that model. It confirms that our understanding of how planetary systems form and evolve is fundamentally correct. This is how science works. You build a model based on observations and physical laws. You make predictions about what you should observe if the model is correct. Then you wait, sometimes for decades, for technology to advance to the point where you can test those predictions. When the observations come in and they match what you predicted, that is a moment of profound validation. Not just of your model, but of the entire scientific method, the whole framework of careful observation, logical reasoning, and mathematical prediction that Sagan championed his entire life. Sagan also understood time in a way that few others have communicated so effectively. He created the cosmic calendar, a thought experiment that compresses the 13.8 billion-year history of the universe into a single year. In that calendar, the Big Bang happens at the stroke of midnight on January 1st. Our solar system forms in early September. The first life on Earth appears in late September, and all of recorded human history, every empire that has risen and fallen, every book written, every war fought, every discovery made, occupies only the last few seconds before midnight on December 31st. On that scale, 3I Atlas is 3 billion years old. It formed in early October of the cosmic calendar, while our solar system was still a swirling disk of dust around a newborn sun. It has been wandering ever since. For the equivalent of 2 months on the cosmic calendar, it has drifted between the stars, covering distances so vast that light itself takes years to cross them. And now, in the final seconds of the cosmic calendar, a species that appeared just moments ago has developed eyes that can see it, minds that can understand what it is, and the wisdom to recognize it as a messenger from the deep past, carrying information about the conditions that existed in a different part of the galaxy billions of years ago. This is the perspective Sagan wanted us to grasp. We are not the center of the universe. We are not even the center of our own solar system. We are inhabitants of a small world, orbiting an ordinary star in the outer suburbs of a typical spiral galaxy. But we are also something extraordinary. We are matter that has become conscious of itself. We are a way for the cosmos to know itself, in Sagan's famous formulation. When we study 3I Atlas, we are not just cataloging a comet. We are engaging in an act of cosmic self-awareness. The atoms in our bodies were forged in the interiors of stars that exploded billions of years ago. The nitrogen in our DNA, the calcium in our bones, the iron in our blood, all of it came from stars. And now those atoms, rearranged into human form, are using telescopes to study another collection of star-forged atoms that has traveled for billions of years to pass through our neighborhood. Sagan wrote in pale blue dot about a photograph taken by the Voyager 1 spacecraft as it left the solar system. At his request, the spacecraft turned its camera back toward Earth from a distance of 6 billion kilometers and took one last picture. In that image, Earth appears as a tiny dot, less than a single pixel suspended in a sunbeam. Sagan reflected on that image and what it meant. From the vantage point of 3I Atlas, Earth would appear even smaller. From the distance this comet has traveled, from the depths of interstellar space where it has spent billions of years, our entire solar system is insignificant, a brief brightening of one unremarkable star among billions. Everything we have ever known, every human who has ever lived, every triumph and tragedy, every civilization that has flourished and faded, all of it happened on that mote of dust. This perspective, Sagan argued, should make us humble. It should make us recognize how petty our divisions are, how absurd our hatreds, how precious and fragile our world. There is no hint that help will come from elsewhere to save us from ourselves. Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Like it or not, for the moment, Earth is where we make our stand. 3i Atlas reminds us that we are part of a larger galactic community, not of civilizations, not yet at least, but of matter and energy, of physical processes that operate everywhere according to the same laws. The chemistry in this interstellar comet is the same chemistry that operates in our bodies. The gravity that shaped its trajectory is the same gravity that keeps Earth in orbit around the Sun and keeps our feet on the ground. We are connected to the cosmos, not through mysticism or astrology, but through the deep physical reality that we are made of the same stuff as the stars and the planets and the comets. Every atom in your body has a history that extends back to the Big Bang. Some of those atoms were forged in the first 3 minutes of the universe's existence. Others were created in the nuclear furnaces of massive stars that lived and died before our sun was born. Billions and billions of years separate us from the formation of 3i Atlas. Billions and billions of kilometers separate its birthplace from ours. And yet here we are, observers and observed, connected by the fundamental unity of matter and the universal laws of physics. Sagan would have loved this. He would have seen in it confirmation of everything he believed about the cosmos, about the power of science to reveal connections that transcend time and space, about the privilege and responsibility that comes with being conscious participants in the universe's unfolding story. Since Sagan's death in 1996, astronomy has been transformed. When he was writing Cosmos and Pale Blue Dot, we had not yet confirmed the existence of a single planet around another star. Today we know of thousands of exoplanets. We have telescopes in space like the James Webb Space Telescope and the Hubble Space Telescope that can study the atmospheres of distant worlds. We have detected gravitational waves from colliding black holes and neutron stars, confirming predictions Einstein made a century ago. We have imaged the event horizon of a supermassive black hole. And now we are cataloguing interstellar visitors. 3i Atlas is the third confirmed interstellar object, but astronomers expect that as our detection capabilities improve, we will discover more, perhaps many more. Statistical models based on the detection rate so far suggest that at any given time, there may be dozens of interstellar objects passing through the solar system, most of them too small or too faint for us to notice. As telescope networks like Atlas expand and improve, as survey programs become more sophisticated, we will catch more of these cosmic travelers in the act of passing through. Each one is a gift, a sample of another stellar environment delivered to our doorstep for free. We do not have to travel light years to study the chemistry of other star systems. They come to us occasionally, if we are patient and watchful. This is the universe Sagan described, filled with connections and exchanges, with matter circulating through the galaxy, forming stars and planets and comets, being expelled and wandering, and occasionally encountering other systems. The Fermi paradox asks why, if the universe is so vast and so old, we have not yet detected signs of extraterrestrial intelligence. Sagan thought deeply about this question. He understood the pessimistic answers, that perhaps technological civilizations destroy themselves, or that the distances are simply too great, or that intelligence is far rarer than we hope. But he also held on to a cautious optimism. He believed that the question was worth pursuing, that the search itself was valuable, that even a negative result would teach us something profound about the nature of intelligence and technology and survival. 3i Atlas does not answer the Fermi paradox. It is not a message from an alien civilization, but it does teach us something about galactic interconnection. It shows us that the galaxy is not a collection of isolated star systems, but a dynamic environment where matter moves and mixes. If we ever do make contact with another civilization, it may be through detection of artifacts or signals that have traveled for millennia, carried through space by patience and the inexorable laws of physics. Sagan's vision was always long-term. He thought in terms of centuries and millennia, of the deep future and the deep past. He urged us to overcome our tendency toward short-term thinking, to recognize that the decisions we make today will echo far into the future. He was particularly concerned about nuclear war and environmental degradation, two existential threats that he saw as tests of our maturity as a species. The same perspective that allows us to appreciate 3i Atlas, this sense of cosmic time and cosmic scale, is the perspective we need to address the challenges facing our own world. Climate change, biodiversity loss, the risk of nuclear conflict, these are problems that require us to think beyond the next election cycle or the next quarterly profit report. They require us to think like Sagan did, as custodians of a rare and precious world, responsible not just to ourselves, but to the generations that will follow, and to the other species with whom we share this planet. This is Sagan's legacy. Not just the specific scientific contributions he made, though those were significant. Not just the books and the television series, though they inspired millions. His legacy is a way of thinking about our place in the universe, a recognition that we are both insignificant, tiny specks in a vast cosmos, and significant, the only beings we know of who can understand that vastness and our place within it. We have the privilege of awareness and the responsibility that comes with it. 3I Atlas will not stay. Already it is speeding away from the sun, heading back into the interstellar void. In a few years it will pass beyond the orbit of Neptune. In a few decades it will be farther from the sun than the Voyager spacecraft. In a few thousand years it will be light years away, continuing its journey through the galaxy, perhaps destined to pass through another star system billions of years from now, long after human civilization has either transformed into something unrecognizable or vanished entirely. But for this brief moment, we shared space with a visitor from the stars. We saw it, studied it, learned from it. We added one more piece to the puzzle of how the galaxy works, how matter moves through space and time, how the universe constantly shuffles and redistributes the elements forged in stellar furnaces. We confirmed what Carl Sagan predicted 4 decades ago, that we are part of a cosmic ecosystem, connected to distant stars by more than just the light that reaches our eyes. Sagan taught us that the cosmos is within us, that we are made of star stuff, that we have begun to contemplate our origins. He taught us that science is a candle in the dark, a way to navigate a world full of confusion and misinformation. He taught us to be both skeptical and open-minded, to demand evidence while remaining receptive to wonder. He taught us that we are responsible for our world, that there is no one coming to save us, that we must save ourselves. The discovery of 3I Atlas is a triumph of the scientific method Sagan championed. It is the result of decades of investment in astronomy, in technology, in the patient work of building better telescopes and training skilled observers, and developing algorithms that can spot anomalies in vast data sets. It is proof that when we commit to understanding the universe, when we ask questions and pursue answers with rigor and creativity, we succeed. As this ancient visitor departs our solar system and returns to the darkness between the stars, we are left with new knowledge and new questions. We know now that interstellar objects pass through our neighborhood regularly enough that we can detect several per decade if we look carefully. We know that these objects carry information about the diversity of planetary systems across the galaxy. We know that Sagan was right about the physics, right about the probabilities, right about what we would find if we looked. But we are left with questions too. How common is life on worlds orbiting other stars? Are there technological civilizations out there, watching their own interstellar visitors pass through their skies? Have they, like us, begun the journey from superstition to science, from isolation to cosmic awareness? Or are we alone, the only eyes the universe has opened to look back at itself? We do not know the answers yet, but we are looking. We are building better telescopes, sending probes to other worlds, listening for signals from the stars. We are doing what Sagan taught us to do. We are exploring. We are questioning. We are thinking critically and dreaming boldly. We are carrying forward the mission he began, to understand our place in the cosmos, and to use that understanding to build a better future for our species and our world. The atoms that make up 3I Atlas and the atoms that make up your body share a common heritage. We are both children of the stars, both part of the universe's grand experiment in matter and energy and complexity. When you look up at the night sky and contemplate the journey of this interstellar visitor, you are engaging in an act that Sagan believed was one of the most human and most noble, the pursuit of understanding for its own sake, the desire to know how things work and what our place is in the grand scheme of existence. Sagan once said that we are a way for the cosmos to know itself. Every time we study an object like 3I Atlas, we prove that statement true. The universe, through us, is investigating itself, understanding itself, marveling at its own complexity and beauty. This is what it means to be human in the cosmic context. We are matter that has gained the capacity for wonder, for curiosity, for science. 3I Atlas came from the stars, wandered for billions of years, passed through our solar system for a brief moment, and will return to the interstellar void. But in that brief moment, it connected us to the larger universe. It reminded us that we are not isolated, that our solar system is part of a dynamic galactic environment, that the universe is far stranger and more wonderful than we imagined. It validated predictions made by a man who looked up at the stars and understood what he was seeing, who translated that understanding into words that inspired generations, who taught us that science is not just a collection of facts, but a way of seeing, a way of being, a way of connecting to the cosmos that gave us birth. Carl Sagan believed that every person carries within them the capacity for wonder and the capacity for understanding. He dedicated his life to awakening those capacities in others, to showing people that science is not cold or remote, but intimately connected to the deepest human questions about who we are and where we came from, and what our future might hold. The story of 3I Atlas is part of that larger story, the story of a species waking up to its place in the universe, learning to read the messages written in starlight and encoded in the trajectories of ancient comets, becoming conscious participants in the cosmic drama rather than passive observers. This is the legacy Carl Sagan left us, not answers but better questions, not certainty, but a method for approaching uncertainty. Not a final understanding of the cosmos, but tools and inspiration for continuing the journey of discovery. As 3I Atlas fades from view, heading back into the darkness, we remain here on our pale blue dot, looking outward, asking questions, seeking understanding, continuing the work that Sagan began, and that will extend far beyond any of our individual lives, into a future we can barely imagine.